What if someone told you that humanity has an expiration date, and that date could arrive within the next few thousand years? Not because of an asteroid, not because the sun burns out, but because that is simply how long civilizations like ours tend to survive before they go silent forever. HAT is not science fiction. That is a real calculation, built from real data, published by real physicists, and it lines up with something even stranger. Every direction we search the sky, every star system we scan for a signal, we find the exact same thing. Nothing. No blip, no whisper, no accidental leak of alien television static drifting across the void. And the deeper scientists dig into why, the more they keep landing on one uncomfortable, inescapable suspect. Astronomers have now confirmed more than 6,000 planets orbiting those stars, with thousands more candidates waiting to be verified. And that number climbs almost every week. One careful study using data from 2 of the most powerful planet-hunting missions ever launched estimated that as many as 300 million of those worlds could sit in the habitable zone around their star, in the narrow band of space where liquid water, and maybe life, could exist. 300 million chances. Just in our galaxy, not the universe. Just this one spiral of stars we happen to call home. Run the math the way scientists have tried to for decades, using a famous formula built specifically to estimate how many communicating civilizations might exist among the stars, and even conservative versions of that equation spit out numbers in the hundreds, sometimes thousands, not one distant neighbor. Decades ago, a physicist named Enrico Fermi was having lunch with a group of colleagues, and in the middle of a casual conversation about flying saucers and the possibility of faster-than-light travel, he asked a question that sounded almost throwaway at the time. Where is everybody? 3 words. But those 3 words launched one of the most haunting open problems in the history of science. If the universe is this old, this vast, and this full of potential homes for life, then where are the civilizations? Where are the signals? Where is the evidence? This became known as the Fermi Paradox, and for more than 70 years, the sharpest minds in physics, biology, and philosophy have been throwing theory after theory at it, hoping something finally sticks. For most of that time, the silence was treated as a mystery to be solved with patience. Build a bigger telescope. One initiative, funded with roughly $100 million and backed by some of the most advanced radio telescopes on the planet, has now surveyed more than 1 million individual stars and over 1,000 nearby galaxies, hunting for any artificial signal that could not be explained by natural astrophysical processes. In recent years, the project began using artificial intelligence systems capable of sifting through that flood of data hundreds of times faster than the methods that came before. More stars, more galaxies, more processing power than any previous generation of scientists could have dreamed of. Entire careers have now been built around this single, narrow pursuit, scientists spending decades of their working lives pointed at the same patch of sky, refining the same algorithms, chasing the same faint hope of a signal that simply refuses to arrive. And still, silence. In one especially telling study, researchers examined a set of 27 exoplanets discovered by one of NASA's planet-hunting satellites, watching closely for the exact moment each planet passed behind its star. The logic was elegant. If a civilization on one of those worlds were broadcasting a signal, that signal should briefly vanish the instant the planet slipped out of view, and then reappear the moment it came back around. It is one of the cleverest tricks modern astronomers have devised for catching a technological signature hiding in the noise. They ran the analysis across all 27 targets. Every single flicker they detected turned out to be ordinary radio interference. Not one alien signal, not one anomaly that survived scrutiny. 0. This is the pattern researchers keep running into again and again on every scale they try. 0 radio bursts, 0 laser pulses, 0 probes, 0 footprints. It's not that we have not found aliens yet. It's that every single method we have ever devised, refined over decades, and now supercharged with artificial intelligence, keeps coming back with the same answer, and that answer is nothing. So scientists started asking a harder question. Not just where is everybody, but why would a universe this vast, this old, and this statistically loaded in favor of life produce this much silence? And the theories that have emerged to answer that question fall into a spectrum, from mildly comforting to deeply disturbing. On the comforting end sits an idea known as the rare Earth hypothesis. The argument is straightforward. A planetary core strong enough to generate a magnetic field that shields the surface from radiation. A large moon to stabilize the tilt of the axis, plate tectonics, to recycle carbon over hundreds of millions of years. A mass extinction violent enough to clear space for new species, but not so violent that it wipes out complex life altogether. Then, on top of all of that, hundreds of thousands of years of evolutionary pressure producing a species with a brain capable of abstract thought, followed by thousands more years of culture and invention before anyone ever points an antenna at the sky. Run those odds honestly, some scientists argue, and it becomes entirely possible that in a galaxy of 400 billion stars, A civilization capable of reaching for the stars might emerge only once, maybe twice. And if the nearest other civilization sits tens of thousands of light years away, their signals simply have not had time to reach us yet. And ours have not reached them either. We are not failing to find our neighbors. We may simply not be playing on the same timeline at all. And history has not been kind to that kind of thinking. Humanity has been wrong before every single time it assumed it occupied a privileged position in the cosmos. So researchers kept pushing, and they landed on something far darker. It is called the Great Filter, a term first coined by an economist studying existential risk. And the idea itself is deceptively simple and genuinely chilling. Somewhere along the long road from lifeless rock to a civilization capable of spreading among the stars, there exists a barrier. A step so difficult, so catastrophic, so nearly impossible to survive, that almost nothing that starts down that road ever makes it through. The entire question hinges on one detail. Is that filter behind us, or is it still ahead? If the filter sits behind us, if the near impossible step was the origin of life itself, or the leap from simple to complex cells, or the jump from single organisms to cooperative multicellular life, then we have already made it through. We are the rare survivors. The silence around us would simply be the graveyard of every civilization that never made it far enough to try calling out in the first place. That would be a relief. That would mean the road ahead of us, difficult as it may be, is at least open. But if the filter lies ahead of us, if civilizations regularly reach our level of development and then hit something they cannot survive, the silence takes on a far more sinister meaning. It means every civilization that ever reached this exact point failed at the very next step. And we are standing at that step right now, today, in this moment. Scientists studying this problem have proposed several candidates for what that next filter could be. Nuclear conflict, runaway climate collapse, engineered pandemics, the exhaustion of a planet's resources before a species manages to establish itself beyond its home world. But one candidate has recently pulled ahead of the rest in a way that has made even seasoned researchers visibly uneasy. Artificial intelligence. A leading radio astronomer, the director of one of the world's most respected centers for astrophysics, published research arguing that the rapid rise of artificial intelligence could itself be the great filter, the very reason advanced civilizations remain so rare across the universe. His reasoning is direct, and it does not require imagining some distant science fiction scenario. He points out that long before any artificial intelligence becomes truly superintelligent or autonomous, it is likely to be weaponized by rival factions within a civilization, each side racing to outpace the other. The speed at which machine systems can make decisions could escalate conflicts far beyond what any human decision-maker ever intended, compressing years of tension into minutes of irreversible action. Under his model, the typical lifespan of a technological civilization, once it crosses the threshold into advanced artificial intelligence, might be measured not in centuries, but in a span potentially less than 200 years. 200 years. Against a galaxy that has existed for billions. Sit with that for a moment. 200 years is barely enough time to invent the light bulb, split the atom, land on another world, and build a machine that can write, reason, and create. It is a blink, a rounding error. Against 13 billion years of cosmic history, it is not even long enough for the light from a modestly distant star system to finish crossing the gap between two neighboring civilizations, which means even a species that did survive its own filter might vanish again before anyone ever heard from it in the first place. And if that estimate holds anywhere close to true across the galaxy, then the silence stops being a mystery and starts looking like a pattern. Every civilization that reaches the point of building powerful artificial intelligence may be walking directly toward the same wall that took out everyone before them. And we are, right now, at exactly that threshold. Humanity has, within the space of a few short years, crossed capability levels in artificial intelligence that no previous generation ever came close to touching. According to this theory, this narrow window, right here, right now, is precisely the moment when civilizations tend to vanish. But the Great Filter is not the only unsettling explanation researchers have put on the table. There is another, arguably even stranger, born not from astrophysics, but from game theory, and it has a name that sticks in your head the moment you hear it. The Dark Forest Hypothesis. The idea first appeared in a work of science fiction, but the logic underneath it is cold, mathematical, and disturbingly plausible. Picture two civilizations existing somewhere in the same galaxy. Neither can communicate faster than the speed of light. Neither can verify with any certainty whether the other is peaceful or hostile. And here is the brutal part of the logic. Even a civilization that is entirely peaceful becomes, simply by growing large enough and advancing far enough, a potential threat to everyone else around it purely by competing for the same finite resources. Under that pressure, the rational move from a purely game theoretic standpoint is not to wait patiently and hope for the best. The rational move is to stay silent, And if you ever detect another civilization revealing itself, to eliminate the potential threat before it has the chance to grow into something you cannot control. If that logic holds across enough civilizations, the entire galaxy transforms into something like a dark forest where every advanced species has learned, the hard way or through simple foresight, to move quietly and listen carefully, because the moment you make noise, something out there might be listening for exactly that. Under this theory, humanity has already been making noise for roughly a century, broadcasting radio waves, military radar, and the accumulated background hum of a technological civilization that does not yet fully grasp the stakes of the game it may be playing. Here's where this theory intersects, uncomfortably, with the artificial intelligence question. Researchers have pointed out that the very act of building increasingly powerful AI, systems that may one day communicate, reason, and act on behalf of an entire civilization, could itself be the loudest technological signal a species can produce. In other words, the tool being built to help a civilization survive might, according to this particular theory, be the exact thing that draws unwanted attention. A civilization quiet enough to avoid detection for millennia could, in the space of a single generation, light itself up across the electromagnetic spectrum simply by building smarter and smarter machines to help it think. Not every scientist agrees that the picture has to be this bleak. In fact, one of the more recent proposals takes a strikingly different, almost anticlimactic approach. And yet, the more you sit with it, the more unsettling it becomes in its own quiet way. A NASA astrophysicist introduced a concept he called radical mundanity. The argument goes like this. We have consistently imagined alien civilizations in one of two extremes. Either they are so far advanced that they have transcended ordinary matter entirely, existing in some form we cannot begin to comprehend, or they are hostile hunters lurking in the dark, waiting to strike. But what if neither extreme is true? What if they are simply ordinary? Picture a civilization that is more advanced than us, but not overwhelmingly so. Not the difference between a simple calculator and a supercomputer, but something closer to the difference between one generation of a smartphone and the next. More capable, better engineered, longer lasting, but still fundamentally bound by the same physical laws, the same limitations, the same slow crawl of scientific progress. Such a civilization would still have no faster than light travel, because nothing in known physics suggests that shortcut exists. Interstellar exploration, even for a civilization somewhat ahead of us, would remain brutally slow, staggeringly expensive, and for the most part, deeply unrewarding. They might send a handful of probes toward nearby systems. They might scan for signals the same way we do. And what would they find? Mostly rock, mostly ice, mostly silence. Exactly what we find every time we point our own instruments outward. Under this theory, the universe is not quiet because it is dangerous, and not quiet because we are impossibly rare. It is quiet simply because it is enormous, almost incomprehensibly enormous, and every civilization out there is boxed in by the same physics we are. Somewhere, another species might have surveyed our little corner of the galaxy long before complex life ever. Crawled out of Earth's oceans, glanced at an unremarkable rock circling an unremarkable star, and moved on without a second thought. Not everyone finds this theory satisfying. Critics argue it projects a very human sense of boredom and apathy onto beings we know nothing about, and that assuming every advanced civilization in the galaxy would settle into the same modest, uneventful existence feels like another quiet act of self-flattery, just dressed up in more pessimistic clothing. Some researchers push back even harder, suggesting that civilizations which survive long enough might not stay recognizably biological at all, evolving instead into something built from silicon and code, advancing so far beyond anything we could perceive that searching for them with a radio telescope would be like trying to find a whisper using nothing but your bare hands. While researchers argue over which of these explanations feels most convincing, an entirely separate group of physicists approached the problem from a completely different angle, and what they found adds a hard mathematical edge to everything that came before it. Two physicists working out of a leading research university in Iran decided to stop asking why civilizations have not contacted us, and instead ask what the silence itself is capable of telling us. Using careful assumptions about how common life and intelligence are likely to be, and folding in decades of failed search results, they calculated an upper limit on how long a technologically advanced civilization can realistically survive if that silence is to make any statistical sense at all. Their conclusion, even under their most optimistic assumptions, was that the typical lifespan of a technological civilization is unlikely to exceed roughly 5,000 years. 5,000 years sounds like an enormous span of time from the perspective of a single human life. It is not, on any cosmic scale. Human civilization, by most measures, is only around 5,000 to 6,000 years old itself, which means, according to this calculation, we may already be approaching the outer edge of our own detectable window. The researchers were careful to frame their number as an upper bound drawn from the silence we observe, not a guaranteed countdown clock, but the implication lingers regardless. If another civilization out there reached our level of development and then quietly ran out its own 5,000-year window before we ever built a radio telescope, then their moment and our moment simply never overlapped. Two lights briefly flickering on in a vast dark room, separated not by distance alone, but by time, and never once catching sight of each other. And then, just as this new mathematical constraint was settling into the scientific conversation, researchers at another major SETI organization uncovered something that complicates the picture even further. It turns out that even if an alien civilization were broadcasting a signal at this very moment, we might be structurally incapable of hearing it. The culprit is something astronomers call stellar space weather. Turbulent plasma surrounding an active star, combined with violent eruptions similar to the solar flares our own sun regularly produces, can physically distort a radio signal before it ever leaves its home star system. A narrow, sharp, unmistakably artificial signal, exactly the kind SETI researchers have spent decades training their instruments to detect, can be smeared and broadened by this turbulence into something faint, diffuse, and almost indistinguishable from ordinary background noise. The lead researcher behind this finding put it plainly. Search systems are built to catch extremely narrow signals, and if a signal gets stretched out by the very environment it was broadcast from, it can slip beneath detection thresholds even while it is sitting right there, waiting to be found. Think about what that means. It suggests that somewhere out there, a message might already be arriving. It might be washing over our instruments at this exact second, and we may simply lack the tools to recognize it as anything other than static. So where does all of this actually leave us? Not with a single answer, but with a convergence. Several independent lines of reasoning built by different scientists, using different methods, in different countries on different sides of the world, all quietly pointing toward the same uncomfortable neighborhood. Life may genuinely be rare. Intelligent life rarer still. Technological civilizations rarer again, and short-lived on top of that. The raw physics of interstellar distance make contact vanishingly improbable in any given moment, and running underneath nearly every one of these threads is the same recurring uneasy thread. The development of artificial intelligence appears again and again across completely independent research as the single most dangerous threshold a civilization is ever likely to face. And here is the detail that should genuinely sit with you long after this video ends. We are not spectators quietly observing this question from a safe distance. We are participants. We are, right now in this exact era of human history, the civilization standing directly at that threshold. We are the ones who just built the very technology that keeps showing up across multiple independent lines of scientific reasoning as the most likely explanation for a galaxy full of silence. Maybe we are the exception. Maybe we are the rare civilization that builds this technology carefully enough, thoughtfully enough, cautiously enough to walk through this filter that seems to have caught almost everyone else. Maybe this becomes the one story in the history of this galaxy where intelligence survives its own intelligence. Or maybe the universe stays quiet for the same reason a room goes quiet after terrible news arrives. Not because nothing happened, but because everyone in it already understands exactly what comes next, and no one wants to be the one to say it out loud. We do not know which version of this story we are living in. Not yet. Every theory on the table, from the comforting to the catastrophic, remains exactly that. A theory, tested against decades of silence and refined with every new study that comes back empty. But for the first time in human history, we are not just asking an old philosophical question for its own sake. We are asking it while standing at the exact fork in the road that the question itself seems to be describing. Somewhere out there, across 400 billion stars, in a galaxy old enough to have produced countless chances for another mind to look up at its own sky and wonder if it was alone, the silence continues. Whether that silence is a warning, a coincidence, or simply the sound of a universe too vast to notice us yet, is still being decided. And in a strange, quiet way, part of that decision is being made right here, on this small planet, by a species that just started building the one thing every serious theory keeps circling back to as the reason nobody else ever got the chance to say hello. We built the telescopes, we built the listening arrays, we built the artificial minds now sifting through the noise, searching for the faintest trace that we are not alone in all this darkness. And somewhere in the process, almost without noticing, we may have also built the very thing standing between us and the answer. Not because anyone intended it, not because there was any single villain, any single decision, any single moment where it all went wrong, but because that is apparently how it goes, over and over, all across a galaxy that has been quietly running this exact experiment for billions of years before we ever arrived to ask the question ourselves. So the next time you look up at a clear night sky, past the handful of visible stars toward the hundreds of billions you cannot see, remember that the silence staring back is not empty. It is loaded with possibility, with probability, with the ghosts of civilizations that may have come impossibly close and never made it past this exact point. And somewhere in that silence is also perhaps us. Not yet a statistic. Not yet a cautionary tale whispered by whatever comes after. Still here? Still listening? Still, for now, the ones asking the question, instead of the ones who went quiet before they ever got the chance to answer it. And maybe that, more than any equation or theory or study, is the part worth carrying with you long after tonight, out into whatever comes next for all of us.